This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Now we learn the energy graph of a spring. So consider a figure which is given below, and if we consider there are object having mass m which is attached to a spring, and this object moves in a simple harmonic motion about its mean position, then its potential energy at any position x can be given by u is equal to half kx square. That is, if I stretch the spring by a distance x or compress the spring through a distance x, then the potential energy at the point x is equal to given by u is equal to half kx square. So there are four figures are given. You have to consider that the object is moving on a frictionless surface, that is mu is equal to 0, and there is no any loss in the frictional force or any other dissipative force. So in this first figure, when the object is at point x is equal to 0 and moving either on the left side or on the right side, that is moving towards positive x direction or the negative x direction with a velocity v. So in this case, if you see that the spring is at its natural length L and there is no any compression or expansion, so because of this the potential energy is equal to 0 while kinetic energy is equal to half ka square, and the energy, total energy E, which is the sum total energy E, which is basically the total mechanical energy. So total mechanical energy is equal to sum of potential energy plus kinetic energy, and it is equal to half ka square. So how we get this, the value of this kinetic energy is equal to half ka square, we will learn later on. Second case, you just consider when the object has moved x distance from its mean position in the positive x direction. So clearly the spring has expansion equal to x, and in this case the potential energy is equal to half kx square. The total energy is equal to half ka square, so the kinetic energy is equal to 1 by 2 ka square minus x square. This is our total mechanical energy. We have to consider only mechanical energy. So total mechanical energy is equal to half ka square, and as the potential energy is equal to half kx square, so kinetic energy is equal to half ka square minus x square. Similarly, if the spring moves in such a way or the object moves in such a way that it comes to a distance x from its mean position in the left hand side, that is spring has already been compressed by a distance equal to x, then again potential energy for compression x in spring. So if we consider the compression x in spring, then the potential energy is equal to half kx square. The kinetic energy is equal to 1 by 2 or half ka square minus x square, and the total mechanical energy E is equal to half ka square. So we may note that at any point of time the total mechanical energy seems to be constant, and actually it is constant, which is equal to half ka square. It's a potential energy which converted to the kinetic energy and kinetic energy converted to the potential energy. Similarly, if I consider the maximum expansion, like if the object moves in such a way that it has moved to a maximum distance equal to a, so at the maximum distance a, it means no further distance it will move, or the expansion will be, the maximum expansion will be equal to a. So at the time of maximum expansion the object stops. So as the object stops, or the velocity at this point will be equal to 0, so the kinetic energy will be equal to 0 and potential energy is equal to half ka square. So the total mechanical energy is equal to 1 by 2 ka square. and in the case of maximum compression, which is the compression equal to A, the kinetic energy equal to again 0, because is at this point the velocity will be equal to 0, so kinetic energy equal to 0 and potential energy is equal to half k square. Total mechanical energy is again half k square. So basically object is moving from distance x is equal to minus a to x is equal to plus a in this way, and at the two extreme we have where we have only potential energy, while we have maximum kinetic energy at the mean position where potential energy is equal to 0. So if I draw if I put the value in this figure, then at this point we have potential energy is equal to 0 at this mean point. At this point, at these two extreme, we have a maximum potential energy which is equal to half ka square, and the maximum kinetic energy will be observed at the mean position. So all those things are written here, that for the extreme position the potential energy will be maximum, which is given by half ka square, and this is because x is equal to plus minus a is the extreme point. Similarly, at the normal point or at the mean position, we have maximum kinetic energy, and it is equal to half ka square, and the total energy, if we add these two energy, then the total energy is equal to total mechanical energy, in fact, is equal to half ka square, because at the extreme point we have velocity is equal to 0 and no kinetic energy, we have only potential energy. So from there we can get also the kinetic energy. The formula of kinetic energy is equal to half ka square minus half kx square, and it's equal to half ka square minus x square. So I just written this all information in a tabular form, and this is our tabular form, that there are four cases, and the first case is the at the mean position we have a spring restoring force will be 0, and the potential energy will be 0, the kinetic energy will be maximum, it is equal to half kx square. The formula of kinetic energy is given by half ka square minus x square, so x is equal to 0 in this case, and the maximum kinetic energy is equal to half ka square, the total energy is equal to half ka square. At the left extreme, that is when the spring have maximum compression equal to a, then the potential energy is equal to half ka square, the total energy again will be half ka square, and kinetic energy will be 0. The kinetic energy will be 0 at the left and the right extreme, where the potential energy will be maximum at these two extreme, and at any general point the potential energy is equal to half kx square if the compression or the expansion will be equal to x, and the kinetic energy is equal to half ka square minus x square. Again the sum, again the value of total mechanical energy is equal to half ka square. So I think all these things must be clear to you. If you have any doubt, you just write in the comment section and I will explain it once again. So based on the above information, we just draw spring energy curve. So the spring energy curve is drawn here. The value of kinetic energy is shown with the green color, while the value of potential energy will be shown with the red color, and the total energy is shown with black color. So as you know that the value of potential energy is equal to half kx square. So this is the equation of the parabola, and as we know that the value of the standard equation of parabola, that is x square by 4ay, will be of this form. So clearly the value of the potential energy curve with respect to x will be a parabola shown by the red color. If you see that the potential energy is 0 at the mean position or at the normal position where we have 0 expansion. So at x is equal to 0, we have u is equal to 0, and at the extreme point, what will be the value of potential energy, it is equal to half k A square. So at the extreme point, the value of potential energy is equal to half k A square. So whether it's left extreme or right extreme, the value will be half k A square. Now if we consider the curve of kinetic energy, so kinetic energy is given by 1 by 2 k A square minus x square. So how we will draw this curve? So this curve is shown by the green line or the green color, where at x is equal to minus a, if I put the value of x is equal to plus minus a in this equation, we get the value of kinetic energy is equal to 0, and at x is equal to 0, the value of kinetic energy will be maximum, and it is equal to 1 by 2 k A square. So the kinetic energy is maximum at x is equal to 0 and minimum at x is equal to plus minus a, where velocity is equal to 0 and we have 0 kinetic energy. So how we get this curve? So from the graph approach, we can also get that the kinetic energy will be maybe written as minus 1 by 2 k x square plus 1 by 2 k A square. So as we have already learned, the graph of x square is equal to 4ay. So if I want to get the graph of minus x square is equal to 4ay, then what we have to do? We have to write that x square is equal to minus 4ay. So here instead of y we have minus y, so we just take the mirror image with respect to x-axis. So if I take the mirror image with respect to x-axis, it comes in this way. Again we have to add our component equal to 1 by 2 k A square. So if I add a component equal to 1 by 2 k A square, the curve will shift upward and the curve will be like that. So in this way we just draw this curve which is shown in this figure. So if you add these two curves, you get the value is equal to half k A square. It's a total energy curve is equal to half k A square, and it is constant throughout the motion. Now again you may have to calculate the value of x at which the potential energy and kinetic energy are equal. So how we will calculate it? You just make potential energy is equal to kinetic energy and calculate the value of x. So potential energy is equal to half k x square and kinetic energy is equal to half k A square minus x square. And if you solve it, you get x square is equal to A square minus x square, and from there you get x is equal to a by root 2. So these points are x is equal to plus a by root 2, and this point is x is equal to minus a by root 2. So at point x is equal to a by root plus minus a by root 2, we have kinetic energy and potential energy are equal. So all these things are written here also, that from the graph kinetic energy changes parabolically with respect to position, while the potential energy also changes parabolically with respect to the position. The total energy remains constant with irrespective to the position of particle, and the fourth point must be equal to at x is equal to plus minus a by square root 2, kinetic energy is equal to potential energy. So from the graph we have get that the value of potential energy is equal to half k x square, and U max or the maximum potential energy is observed at x is equal to plus minus a, which is at the extreme point, and the value is equal to half k A square, and the minimum potential energy is observed at the mean position, that is x is equal to 0. Similarly, the kinetic energy is given by the formula half k A square minus x square, and the maximum kinetic energy is equal to half k A square, which is observed at x is equal to 0, and the minimum kinetic energy is observed at the extreme point, that is x is equal to plus minus a, where velocity is equal to 0, and the total energy is constant and it is equal to half k square for all positions.